Hello, Manta Rays. Today we are going to be learning about the greatest common factor, but out in the real world. So how do we apply our new learning to the world around us? How would we need to use, or why would we need to use, the greatest common factor if we're out in the world? What types of scenarios? So we're going to use the same strategies as yesterday with either the ladder method or with your factor pairs. You choose whichever strategy you prefer, and we're going to apply it to the real world. So let's start with, there's my pen, it was in my pocket. Okay, so we're gonna start with the first real life situation. We are filling pinatas for a party. And in our pinatas, we want to know what identical groups we can create with no gifts left over. So what's the greatest number of pinatas that we can fill? So we have 18 kazoos, and there are 24 mints, and 42 lollipops. Okay, and we want to know, the question is, what is the greatest number of pinatas? Okay, so what is the greatest number of pinatas that we can create? We're going to do this the exact same way as we did before. We're going to start with just these numbers. It doesn't matter if it's 18 kazoos. It could be 18 cars. We're going to still use that number 18. Could you imagine a car in a pinata? Oh my goodness, missing letter. Okay, so we have 18. We also have the number 24, and we have 42. So we're going to go through and we are going to find the factor pairs of these three things. So let's first start with kazoos. 18 is the number that we want to make. So 1 times 18, that's one of them. And 2 and 9, there's another factor pair. And 3 and 6, there's another one. 4, nope, that one's 16. And 7, no. 8, nope. But 9, so it just circles back around. So we are good right there. Okay, so that is our first that's our first set of numbers. Okay, now let's look at the mints. How many mints can we make? All right, let's look at the mints. We want 24 mints. 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5, nope, that would be 20. So I think, because 5 times 4 is 20. Okay, so that's it, because then we get to 6 again. All right. Last one is 42. All right, let's check out 42. Let's see, do I have a different color? Let's use orange. We haven't used this color in a while. All right, 42. We have 1 and 42. And we have 2 and 21. And 3 and 14, because 4 is 12. And not 4, not 5, but 6. 6 and 7 equal 42. And then we would be back on ourselves. So there we go. All right, let's look for the greatest common factor. What is the factors that they have in common? They both have one, or all three of them have ones. They all have twos. They all have threes. They do not all have fours. Ooh, 6. Look at 6. And 9 and 18. Nope and nope. So the greatest common factor that we can pull out, the greatest common factor is 6. So we can make 6 pinatas. Woohoo! Look at us go. That's a lot of pinatas that we can create. All right. So let's look at another problem. So this is example A. And now let's do example B. And from example B, we will be able to try to use the ladder method this time. So let's try to do the ladder method so that you can see it in action again. Because I know some of you really enjoyed that method. Others of you just really didn't. So, okay. We are having a party still. So many parties in math. Lots to celebrate. Okay, and we are making appetizer platters for the party. There are 16 fruit kebabs, 32 cheese cubes, and 40 meatballs. It's a lot of food to put on top of these like plates, okay? And we want identical groups of appetizers because, well, it's math. And so, of course, we want identical groups. So how many appetizers can we put, or what's the greatest number of appetizer platters that we can make? So what's the greatest number of platters that we can make? So let's start out first talking about the question. What is the greatest number of platters? All right, so the greatest number of platters that we can make with no food left over. We have 16 fruit kebabs. Fancy fruit. And we have, maybe it's like one of those fruit arrangements or something. Okay, and then we have 32 cheese cubes. So precise. Okay, and the last one, 40 meatballs. Not 41, not 40 and a little chunk of meat. It is 40 meatballs. Whew. I don't know who comes up with these things. Okay, so let's start with 16. 32 is a different color. Let's do that one in blue, which now looks like purple. Sorry, guys. And the last one is 40. All right, let's do this ladder method. Are we ready? We have 16, 32, and 40. This is a really wide ladder. Okay, I know I can pull a 2 out of each of these because I'm a mathematician and I can pull 2s out of numbers. That's right. Okay, so this 2 is going to become 2 times 8 and 2 times 16 and 2 times 20. All right, now, right, 2 and 6 is 12. 12 carry the 1. Okay, yes. Man, Miss Englander, your math is getting bad at night. Okay, I need to record my videos in the morning maybe. And the next ladder step, pull out another 2 because they're all evens. All right, 2 times 4 and 2 times 8 gives me 16 and 2 times 10 gives me 20. How am I going to keep pulling out 2s? Okay, here's another level. 2 times 2 is 4, and 2 times 4 is 8, and 2 times 5 is 10. Okay, I cannot go any further on this ladder because if I do, I won't be able to pull something out of here because the 5 is prime and 4 and 2 do not make 5. 2 is also prime, but it's even and 4 is even. We almost could have. Okay, so now we're going to look at, where's my highlighter? There we go. Okay, we're going to look at these numbers here on the side for greatest common factor. All right, so I have 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. So my number of platters that I can make is 8. I can make 8 platters, and all of those meatballs will fit evenly on the 8 platters. All of those cheese cubes will fit evenly on those 8 platters, and same thing with my fruit kebabs. All right, so it is your turn now to do the greatest common factor, so to find the greatest common factor in a real life situation. So I'm going to turn the page and give you a story problem, and you have to find the solution to this story problem. Are you ready? All right. You fill bags of cookies for your friends. You are so nice. First you're throwing parties for your friends, and now you're going to give them cookies. All right. You bake 45 chocolate chip cookies and 30 peanut butter cookies and 15 oatmeal cookies. Don't worry about allergies. They don't exist in math right now. You want to have identical groups of cookies in each bag. So no cookies left over, and you want every bag to have the same cookies. What is the greatest number of bags of cookies that you can make to give to your friends? So how many friends are going to get cookies? So let's see here. How many bags of cookies can you make? All right, and I need to label this as a try it. Okay, what did we say? We had 45 chocolate chip. So 45 choco chip. And you also had 30 peanut butter and 15 oatmeal. All right, I don't know if they have raisins or not, because I don't know what you made in your oatmeal cookies. It just says oatmeal. So hit pause so you don't hear me solving this for you, and then come back when you are ready. All right, because I prefer the ladder method, I am going to use the ladder method to solve. If you don't like the ladder method, you may use factor trees. You may also use factor pairs. Your choice. You do you. You pick out what math you love the most, and you do whatever works for you. There is no one strategy to use. So 45, 30, and 15 are the numbers I'm looking for. All right, 5. I instantly see 5 because I know 5 and I know 5 can go in here. So I'm going to pull out a 5. And this becomes 9. And 6 and 3. Okay, I also see on my next level, I see that all of these have a 3 in common. 3 times 2, 3 times 1, and 3 times 3. Look at that. So my ladder is completed. It's only 2 steps. And now I'm going to multiply those together. So I have 3 times 5, and that equals 15 bags. I can make 15 bags of cookies. That is awesome. I hope that when you give out one of these bags of cookies that you give one to me. Just kidding. Okay. It is your time now to answer your essential question. How do we find the greatest common factor in the real world? Why is it important? What do we need the greatest common factor for out in the real world? And then go ahead and put your level of understanding out to the side. 1, still no idea what you're doing, Miss Englander. I need help. I'm going to come and ask. 2, I'm going to keep practicing. I am going to get this. I just need a little bit more practice. Or a 3, I totally understand this. I know how to use the greatest common factor methods. And it doesn't matter if it's out in the real world or just regular old math. I've got it down. All right. Thank you for your hard work today, Manta Rays. And you may go and do your practice work or come and see me in the Google Meet and ask for help. Have an awesome day and make it a great day the Manta Ray way.